In this video, I'm going to talk about the chain rule for differentiation. If you have a composite function defined as y equal to f of g of x, to find the derivative of y with respect to x, you have to use the chain rule. And the formula is y prime is equal to f prime of g of x times g prime of x. So you find the derivative of the outer function and then you multiply by derivative of the inner function. But based on my experience, most students get confused when we talk about the chain rule because they will have problem identifying f and g of x. In order to avoid this problem, I'm going to show you three different cases where you must use the chain rule. Let's just start with case number one. If you have a function like y equal to f of x to the power of n, and here n is a real number. So anytime you have a function to the power of a real number, you have to find the derivative of y, you have to use the chain rule. And the formula is y prime is equal to n, so you bring the exponents down, multiplied by f of x to the power of n minus 1. And then you multiply by f prime of x. So this is very similar to the power rule, which is just for x to the power of n, but the extra part is multiplying by derivative of f of x. For example, if you have y equal to x plus 1 to the power of 4. So this is like a function of x, which is x plus 1 to the power of a real number. So then to find the derivative, y prime, you start with the power rule. So you bring down the exponent 4, multiply by x plus 1 to the power of 4 minus 1, which is 3. And then you multiply by derivative of the function x plus 1, which is just 1. So that's case number one. Case number two is when you have y equal to b to the power of f of x. And here b is a positive integer. In this case, to find the derivative of y, you have to use the chain rule, which is going to be y prime is equal to b to the power of f of x. So you repeat the function, you write it again here, multiply by derivative of the exponent, which is going to be f prime of x, and then you multiply by ln of b. For example, if you have y equal to e to the power of x squared. So in this case, e is b and x squared is f of x. So if you follow the formula for y prime, we have to write down e to the power of x squared, and then we multiply by derivative of x squared, which is 2x, and then you multiply by ln of e, which is just 1. So that was case number 2. Case number 3 is when you have y equal to a trig function of f of x. Now, this trig function is a trigonometric function, and it can be sine, cosine, tan, cotan, secant, cosecant, any of the trig functions. So then in this case, y prime is, you start with derivative of the trig function. So I'm just going to write it as trig prime of f of x. So you differentiate the trig function, and then you multiply by derivative of the function inside. So multiply by f prime of x. For example, if you have y equal to tan of x to the power of 4 plus 2x. So then in this case, y prime is equal to, so the trig function is tan, and derivative of tan is secant squared. So it's secant squared of x4 plus 2x. Then you multiply it by derivative of the function inside. So it's derivative of x4 plus 2x. which is 4x cubed plus 2, and that would be the derivative of tan of x4 plus 2x.